Hello guys, I'm back with another part of binomial theorem. In the first part of binomial theorem, I gave you a realization of binomial theorem. I made it clear there what is essentiality of this binomial theorem with reference to physics or with reference to mathematics. I also gave a glimpse of this binomial theorem in the previous video that it has two versions. First version is applicable for only positive integer, and second version of this binomial theorem is applicable for any index. It may be positive, negative or fractional even. So now I will discuss this binomial theorem into two main subtopics, that is one is applicable for positive integer, second is applicable for any index. But I will leave the first one as such because it's not used very often in physics. This is only used for positive integer, and it will be very futile for me to discuss it in a detail, because at the end of the day you will not find its application in physics a lot of places. So I will only discuss second part or second version of it, that is binomial theorem for any index. So here I am going to start it. Binomial theorem. So it has two versions. First version is applicable for positive integer, and second version of binomial theorem is applicable for any index. It may be positive, it may be negative, it may be even fractional. Already I made it clear in the beginning that this version of binomial theorem is futile to discuss here because it's not used in physics very often. So the part of binomial theorem which is used in lot of cases, in lot of ways, or in a lot of situations, that is binomial theorem for any index, positive, negative or fractional. In this version of binomial theorem, there is involvement of a type of concept in mathematics, that is combination. And in this part, we will use another procedure, we will use a new method where there will be a concept of factorial, and there will be a simple way, or there will be a simple procedure to go ahead. And I will give you a simple idea how you will write the successive terms by looking into the pattern of preceding terms. So I will focus on this version. So what is binomial theorem for any index, positive, negative or fractional? So let me discuss this version in detail. For example, if you have 1 plus x whole raised n, this will be your binomial where your index is n, and I am mentioning this concept here that n can be positive, negative or fractional, because I am discussing this version of binomial theorem. So that means n can be positive, negative, fractional. So if you have given a binomial 1 plus x whole raised n, n is simply known as index in physics language or in mathematical language. Here we have two terms within the braces, that means we are dealing with binomial, and the index of this binomial is n. N can be anything, and n is already, it's positive, negative or fractional. So how you will expand it, how you will evaluate it? By looking into this theorem, binomial theorem. See how I will write it. 1 plus x whole raised n, it is simply equal to, you have to write first term as such, that is first term is 1. plus second term. When you want to write second term, you have to simply write n with x, or I can simply say you that you have to bring n down and multiply it with the second term. So second term will be n x plus. Now I have to write the third term. What will be the procedure for writing the third term? You have to write the coefficient of the preceding term, that is n, and then you have to decrease value of n by 1, that is n minus 1. Look into the pattern. Here in the first term there is no involvement of the x, but in the second term the power of x increases by 1. So that means in the third term the power of x will also increase by 1. So I will write it here x square. Then you have to divide it. What will be your exponent? You have to write it here, the 2 factorial. What will be the exponent with the x? You have to divide this term by that factorial, that's 2 factorial. Now I hope you have understood it. I hope you have got an idea, or I'm supposing here that you have got an idea how to write the fourth term. So what will be the fourth term? So it will be the coefficient of the preceding term, that will be n into n minus 1. Now you have to decrease value of n further by 1. So that is n minus 1. I have written n minus 1 in the preceding term. So here I have to write n minus 2. You have to decrease it by 1 by 1. So I have written the coefficient of the preceding term in this place, that is n into n minus 1. Then the term I have introduced, n minus 2, you have to decrease the value of n 1 by 1. So that means the term which is multiplied with it will be n minus 2. Now what will be the x? X will be your x cube, because the value of x, it's increasing 1 by 1. Now I will divide it by 3 factorial, so on up to infinity. This will be your procedure. So this is the evaluation. This will be the expansion of this binomial where your index is anything, where your index may be positive, negative, even fractional. So this is the procedure of evaluating the binomial. I hope you have got an idea of writing the pattern, or you have got an idea how to write the successive terms in this expansion. Now I will give you an example to make it understand very clearly. Suppose if you have 1 plus x whole raised 2. In the previous video you have already got an idea, or you're already familiar with this identity a plus b whole square, that's equal to a square plus b square plus 2ab. So I already know its value. If I write it here, 1 plus x whole raised 2, it will be equal to 1 square, then we have x square, then we have 2 into 1 into x, that will be 2x. So if I evaluate this binomial in this way, I have to, there must be a result which will resemble with it. There must be the value which must be equal to this value. So if I evaluate this binomial by this form or in this pattern, I should get the value of 1 square plus x square plus 2x. So if I write it further, it will be 1. Then we have x square plus 2x. So let us suppose, or let us use this binomial theorem for this expression, and the value should be 1 plus x square plus 2x. So let me go into detail. What will be the procedure of writing the terms? So first term is written as such, 1. Then second term is written by bringing down exponent 2 and multiplying it with x. So second term will be 2x. Then the third term will be n into n minus 1. That means you have to write the coefficient as such, that's 2. Then you have to decrease its value by 1, that is 2 minus 1. Then here the value of the exponent of x is 1. Now it will be increased further by 1. That will be x square. Here it's x raised 1. Now we have x square. Then you have to divide it by 2 factorial plus what will be the third term. So I will not write here the fourth term. Why? Because in this expansion, when I write the fourth term, that will be 2 into 2 minus 1. So if I write it here, 2 into 2 minus 1, that is the coefficient. Then you have n minus 2, that is 2 minus 2. 2 minus 2. Then the power of x will increase it further by 1, that's x cube divided by 3 factorial, so on. So I will focus only on 3 terms because 1 plus 2x plus 2 into 2 minus 1 x squared divided by 2 factorial plus the third term will be 0. Why? Because in the middle I have 2 minus 2, that will be 0. This whole term will be 0. And after going ahead, after going into successive terms, after going ahead with the successive terms, there will be 2 minus 2. That means all the terms will be 0. In nutshell, your terms will be only 3. And I have made it clear in the first video what will be your exponent. If your exponent is positive, that means your terms will be 1 more than that index. That means your terms will be 3. So in this expansion, I'm getting the same result. I'm getting only 3 terms. So if I evaluate it further, so I have not mentioned here what is factorial first. So let me clear this factorial first. So if I write 2 factorial, what is 2 factorial? 2 factorial simply means you have to move, you have to go in reverse direction, or you have to move in a reverse direction till you reach to 1, but in a product form. That means 2 factorial is equal to 2 into 1. What will be your 3 factorial? That means you have to start from 3, then going into reverse direction in a product form and reaching to the 1. That is 3 into 2 into 1. What will be your 4 factorial? It will be 4 into 3 into 2 into 1. Then getting its value, 2 factorial will be 2. 3 factorial will be 6, and 4 factorial will be your 4 into 3, that's 12, 12 into 2, that's equal to 24. And if you go into my first lecture on log, I have mentioned a concept of factorial there, but here I am using it, that's why I am reminding you about this factorial, what is its use. So now I can write these terms in the simplified form. So 1 will be written as such, that's 1. 2x will be written as 2x. Then plus, what will be your value here? That is 2 into. What will be your 2 minus 1? That will be 1. Then you have x square. Already I have found that's 2 factorial is equal to 2. So I will divide it by 2. So your value will be 1 plus 2x plus 2 and 2, they will cancel, plus x square. If you compare this value with it, so you will find the same result. What will be the first term? 1. I'm getting the term 1. What will be your second term? It's x square. You don't have to confuse yourself. There is simply the rearrangement. I can write it here like 1 plus, I will write second term as x square. Then we have 2x. This is addition. There is no there is no confusion in it. It will not create any kind of problem. So 1 plus x square plus 2x. So I am getting the same value. I wrote 1 as such. Then I shifted this third term to the second place. Then we have x square. Then you have 2x. The result is same. So this will be the concept which I am using in the binomial, like in gravitation, like in ab initio method, or in further concepts of physics. I hope you have got an idea of this binomial theorem, how you can evaluate it for any index. Let me clear some points here. If you have now 1 plus x whole cube, you have to evaluate it. You have to evaluate it in a same manner as I discussed. But the different procedure or the difference will lie in this here, in this concept here, that is your exponent is 3, your terms will be 4, and here your index is 2, the terms are 3. That is, terms will be always n plus 1. Getting idea of this binomial? Was good. So now look into this. Now we will discuss some important points related to binomial theorem. I hope you have got an idea of evaluating or expanding the binomial where your index is anything. Now let me go into important points of this binomial theorem which will help you in a lot of cases. First, I will discuss for any index. As this version of this, the given version of binomial theorem is applicable for any index, that means your n is positive, it may be negative, it may be fractional. Now, I will make it clear here. If your n is positive, will you have infinite number of terms or will you have discrete number of terms? If your n is negative or fractional, what will be the expansion, or do you have any last term or not? In the example as I mentioned in this 1 plus x whole raised n, that is whole raised 2. You have noticed it, you have realized that the index is 2. That means if your index is positive, that's 2. Your terms are 3. That means if your index is positive, you definitely have discrete number of terms, because at certain stage of this expansion, your expansion will terminate, your expansion will finally reduce, or you have a last term in this case. That means if your index is positive, there will be definitely a stage where this expansion will terminate. As you already saw in this example, you have got 3 terms, because after going away or after moving ahead from this this third term, you have realized that all the terms now reduce to 0. That means you have only 3 terms. But if your n is negative, or if n is fractional, that means you will not find a term, or you will not get a stage where your expansion will reduce to 0. That means the expansion will go up to infinity. You don't have any last term. So you have to memorize one point here. If n is your positive, if n is positive integer, if n is your positive integer, that means you have a last term. You have a last term. That means your expansion will terminate at a certain stage of expansion. But if your n is negative, if your n is negative or fractional, this expansion will not terminate anywhere. It will reach up to infinity. That means you don't have any last term. This will be the first point, which is very important with reference to binomial theorem. So you have to memorize one point here. If your n is positive integer, you have discrete number of terms. That means at a certain stage of this expansion, your expansion will terminate. You definitely have a last term. Like if your index is plus 2, your terms will be 2 plus 1, that means 3. If your index is 3, your terms will be 3 plus 1, that is 4. If your index is plus 100, that is 100, your terms will be 100 plus 1, that is 101. Or if your terms are 1000, if your index is 1000, your terms will be more than value of 1 by that index, that is 1001. So just memorize this point. If your index is positive integer, you definitely have a last term, or your expansion will terminate at a certain stage of expansion. But if your n is fractional or if it is negative, there will be no term. This expansion will reach up to infinity. This will be the first point. Now I will discuss second point. Second point is, if I assume if value of x is very less as compared to 1. If I assume that the value of x is very less as compared to 1, it will be a special case in this binomial theorem, because if your value of x is very less as compared to 1, then only two terms are significant. Why only two terms are significant? Because after going ahead from term number second, the third term, fourth term, fifth term, the value of these terms will be very less, which I can neglect. Because you know that if your value is suppose 0.1, if you square it 0.1, if you square 0.1, it will be 0.01. So it reduces further. That means in the binomial expansion, because in the binomial expansion, after going ahead, after looking into the successive terms, the exponent of x increases by 1. Now first term is 1, second term is that's nx, then you have x square, then you have x cube, then you have x raised 4. If I assume here the value of x is very less as compared to 1, that means you have to square that x. That means x square, then you have x cube, then you have x raised 4. The value of those terms will be very less, which I can neglect. So in that case, 1 plus x whole raised n, it will reduce only up to two terms. Then 1 plus x whole raised n will be 1 plus nx. So I hope you have got it in your mind. Why I have not written other terms? The reason is simple, because x is very less as compared to 1, and after squaring that x or getting cube of x or going ahead, the values will be very less, which I can neglect. So my binomial will reduce only up to two terms. Then in that case, you have 1 plus x whole raised n will be equal to 1 plus nx. And this will be the important result which will help you in gravitation or in lot of cases of physics. This will be the very important result, because in those situations I will try to make value of x very less as compared to 1. Then I can use this approximation and I can reduce this whole binomial only up to two terms. This is the very important concept which is used in the entire physics. Let me give you an example of a situation where you can use this concept. For example, if first of all I will rub it. Now let me go into this problem. You have under root 6, under root 26. You have to find the value of under root 26, because 26 is not perfect square. You will not be able to find its value, because if it is under root 16, then it will be simple. Under root 16 is equal to 4 or minus 4. Now I have to find the value of under root 26. There is no procedure for getting the value of under root 26, but this binomial theorem will assist you. It will give you an idea how to write the value of under root 26, but it will be the approximate value. It will not be the exact value, it will be the approximate value. So under root 26, I have to write its value. So what will I do? I will first convert it into binomial. I have to make it first binomial. So what will I write here? So what will I write under root 26? I can write under root 26 like this. I can break this 26 into two terms, like 25 plus 1. And you know that the value of this square root in exponential notation, that is 1 by 2. So root means 1 by 2 in exponential notation. So 25 plus 1, I have not improvised it. The value is same. I have used only the concept of binomial to evaluate it, because I have to construct first binomial, then I can evaluate it through this binomial theorem. So I wrote 26 as 25 plus 1 because it will be again 26, and this is not a different form because root is equal to 1 by 2 in exponential notation. Now what will I do? I already told you that I will try to make it here the value of 1, then the value in the next place or in the second place I will try to make it very less as compared to 1. So what will I do it? So 25 plus 1 whole raised 1 by 2. I will take 25 out in the inner part. So what will be the further simplification? Take 25 out. What will be in the first place? It will be 1 plus. In the second term, I don't have 25. So when you take 25 out, you have to write 25 in the denominator. So I will write 1 divided by 25. It will be again 25 plus 1. Why? 25 1 into 1, that will be 25. 25 into 1 by 25. 25 and 25 will cancel. It will be again 1. Then you have whole 1 by 2. You know the law of exponent like this. If you have a into b whole raised, suppose you have exponent n. This exponent will be for a as well as for b. So I can write it here, a raised n into b raised n. Similar cases here. This 25 will be your first term. This term within the braces, it will be your second term. You have to write this exponent 1 by 2. You have to write it for 25 as well as for 1 plus 1 by 25, because this will be, this entire term will be considered as a unit. So 1 by 2 will be written for it. So 1 by 2 I can write exponent 1 by 2 with 25 into, now with this term 1 divided by 1 plus 1 divided by 25 whole raised 1 by 2, by simply using this law of exponent, because exponent will be for 25 as well as for this entire term, because this is in the product form. So what will be your 25 raised 1 by 2? This is simply square root of 25. What is square root of 25? That is 5. I'm getting only positive square root into. See, 1 will be written as such plus 1 divided by 25. When you go into decimal expansion, 1 divided by 25 will be 0.04. Simply dividing 1 by 25, when you evaluate it or when you expand it, you will get a value of 0.05. 1 by 25 is simply equal to 0.05. Then you have power 1 by 2. Then going further, it is 5 into. Now evaluating this. So if you look into this part, this will be just neglecting the 5 which is outside the braces. So look into this concept. This is binomial because at the first place you have 1, at the second place you have 0.04. Here this is x. This x is very less as compared to 1. So I can use approximation. That means you have to write only 2 terms. And in that situation, 1 plus this x is your 0.05, 1 plus x whole raised, and it will be equal to, it will be reduced only up to 2 terms. So it will be your 1 plus n is your 1 by 2. 1 by 2 will come down and it's multiplied with 1.04, because according to this 1 plus x whole raised n, that will be equal to 1 plus this exponent is multiplied with x. But when you have to write this, when your x is very less, when x is very less as compared to 1. So the same case is here. I will write it here, 1 plus this exponent is 1 by 2. It is multiplied with this x, 0.04. Are you getting me? So now what will I write it here? 5 into 1 will be written as such plus, so when you simplify it to 1 r, to 0 r, to 0 r, to 2 r, it will be 0.02. So evaluating it further, 5 into 1 plus 0.02, it will be your 1.02. Now multiplying 5 with this 1.02, what will be your value? This will be simple, 5 into 2, that's 10. So 5 0 are 0, 1 will come as such, 5 1 are 5. And you have to write point up to 2 places like here. So it will be your value, that is 5.1. That means root of 26 is equal to 5.1. It will be your approximate value. Why? This is approximate value, not the approximate value in real senses, because I have used the concept of this. So the value will be 5.1 because I have assumed that the x is very less as compared to 1, and for that I made a construction. That means under root 26, which you find very difficult to solve by using ordinary algebra, by using a simple calculation. In this binomial expansion, we found it that it's simple to get the value of under root 26. So under root 26 is 5.1. So got it? So this is a simple example to use binomial theorem to get values of these complicated problems. So I hope you have got an idea of binomial theorem. If you have any kind of question, you can write it in comment box. And if you find it very interesting, please subscribe my channel and hit the bell icon. And I will now upload these videos on consistent basis so that you will be benefited from this mathematics. It's basically a mathematical tool. It will help you a lot. So till then, study hard.